Hello everyone. In the last video we have discussed some important properties of ultrasonic waves. So now we are going to see some methods to generate ultrasonic waves. We know ultrasonic waves are needed for many applications in both industrial as well as medical field. So a variety of techniques have been developed to generate ultrasonic waves like the electrostatic method, Galton whistle method, piezoelectric method as well as magnetostriction method. In your syllabus, two methods are specified, which are the piezoelectric method as well as magnetostriction method. So let's see what is magnetostriction method first. So any generation method involves making use of a dense material, to rapidly vibrate in a medium so that the particles in the medium will start to vibrate with the same frequency and ultrasonic waves will be generated as a consequence of it. So this is the general principle behind any method of generation of ultrasonic waves. Let's see what is the method of making a dense material vibrate longitudinally to create ultrasonic waves in this method. So here the principle in action here is called magnetostriction effect. It will not be familiar to you. Let's see what is magnetostriction effect. So ferromagnetic materials like nickel or iron, when taken in the form of a rod, when it is placed in between the poles of a magnet, it will experience a strong magnetic field along the length of it. Then the elastic property of a ferromagnetic material will change due to in the presence of a strong magnetic field, and that the rod will expand or contract linearly. And due to the linear expansion and contraction, the particles in the medium will also vibrate with the same frequency. Now, if the applied magnetic field is alternating, that is an alternating magnetic field is applied along the length of the ferromagnetic material, then the rod will be vibrating rapidly according to the frequency, depending on the alternating frequency of the magnetic field. And due to the rapid vibration, resonance, the natural frequency of the rod, when the natural frequency of the rod becomes equal to the frequency of the alternating magnetic field, resonance happens, and during resonance the rod will be vibrating very rapidly with maximum amplitude, so that particles in the surrounding medium will also vibrate with very large amplitude, and ultrasonic waves will be generated and propagated through both ends of the rod. So this is the basic principle employed in magnetostriction method. Now let's see what is the experimental setup we employ for the generation of ultrasonic waves in this method. So any oscillating circuit will basically have three main components, which are one, tank circuit. A tank circuit means any combination of an inductor and a capacitor. See, there is a inductor L1 and a variable capacitor C parallelly connected. This will form a tank circuit here. And the second important component will be a transistor to amplify the signals. Here we are taking an NPN transistor in the CE configuration, and the emitter lead is properly grounded so that excess current in the transistor and the circuit will be going to the ground, so that there is no damage to the amplifier. And there is a third important component in a oscillator circuit is a feedback coil. Here the feedback coil is an L2, it is an inductor. So these are the basic components. Here you can see that there is a battery and a milliammeter that provides necessary biasing conditions for this amplifier, and this is the tank circuit, and this is the specimen rod, which is a ferromagnetic rod, which will be either an iron rod or a nickel rod. And you can see that this rod is clamped vertically, so that there will be no vertical oscillations. The rod is maintained or clamped in such a way that it is free to vibrate only longitudinally, and the vertical oscillations are restricted. Now let us see what happens when the battery is turned on. So before turning on the battery, we have to magnetize the specimen rod. The ferromagnetic material which is clamped at the middle is actually made magnetized, pre-magnetized before turning on the power supply by passing a DC current through it. So, the rod now has some magnetization in it. Now, when you turn on the battery, current starts flowing through the circuit. The current reaches the capacitor and the capacitor starts to charge, and when the capacitor charging gets completed, it will discharge the charges through the inductor L1. Now, the inductor L1 and C, the tank circuit will produce a electrical oscillations with a frequency 1 by 2 pi root of L1C. This formula you might be very familiar with from the +2 classes. For any parallel combination of LC circuit, you will have a frequency, electrical oscillation frequency of this form. So, the tank circuit L1 parallel C produces electrical oscillations of frequency 1 by 2 pi root of L1C, and hence you can see that due to the flow of this current through the flow of charges through the inductor L1, an induced magnetic field will be produced in the tank circuit. So, due to the flow of current, a current carrying conductor will induce a magnetic field. This is a basic idea of electromagnetic induction. So, due to this tank circuit will produce an induced magnetic field parallel to the length of the ferromagnetic rod. So, when a strong magnetic field is applied parallel to the length of a ferromagnetic rod, magnetostriction effect comes into play, and hence the elastic properties of the rod will be changing, so that the rod will be expanding or contracting depending upon the frequency of oscillation of the tank circuit. So, the rod will be longitudinally vibrating. So, due to this longitudinal vibration, the coil L2 will also experience some magnetic induction. There is a rate of change of flux in the coil L2, and due to the rate of, according to Faraday's law, due to the rate of change of flux, you can induce a magnetic field in the coil L2, and due to that induced magnetic field, and induced current, induced EMF will be formed in the coil L2, and this induced EMF is fed to the emitter base junction or the input junction of the transistor amplifier, and the whatever EMF is fed to the transistor amplifier gets amplified here, and it will be fed back to the tank circuit through the collector lead. Now, the induced EMF in the coil L2, which is the feedback coil, will be fed back to the tank circuit. Whatever EMF that is produced in the coil L2 will be in phase with the induced EMF in the L1 circuit or the tank circuit. So, both these currents will be superimposing positively or constructively, and hence the electrical oscillations of the tank circuit will always be maintained always. So, there is a positive feedback mechanism coming into play here due to the coil L2. Now, the current through the tank circuit should be so adjusted that the frequency of vibration of the natural frequency of vibration of the rod should become equal to the electrical oscillation frequency, then only resonance will happen. So, for that we can adjust the value of current through the circuit. For that we can adjust the value of capacitance. By varying the value of capacitance, you can adjust the current through the tank circuit. At one stage, at one particular value of current, you can see that the natural frequency of vibration of the rod will become equal to the frequency of the electrical oscillation frequency of the tank circuit. The natural frequency of vibration of the rod is given by F2 is equal to 1 by 2L into root of E by rod, where E is the Young's modulus of the material, material of the rod, and rho is the density of the material, and L is the length of the rod. So, when the frequency of vibration of the rod F2 will become equal to F1, 1 by 2 pi root of L1C, resonance will happen, and due to resonance, the vibration of the rod will be maximum. The rod will start to vibrate with maximum amplitude. Hence, the particles in the surrounding medium at both ends of the rod will also exchange the same vibration and they also starts to vibrate with the same frequency. Hence, ultrasonic waves will be generated from both ends of the rod. So, this is how you generate ultrasonic waves by using a ferromagnetic material, by making use of the change in the elastic properties of a ferromagnetic material in the presence of a strong alternating magnetic field. So, this method can be used to generate ultrasonic waves having a frequency up to 3 megahertz, that is the upper limit, and it is a very expensive method. So, it is not really convenient. So, we will come up with another method that is more compact and convenient and is more efficient, that is the piezoelectric